Hi guys, it's Ms. Flanagan. Today I wanted to talk about naming and bonding. And so when we talk about bonding, there's really three different main types. The first is ionic. Ionic bonds exist between a metal and a nonmetal, and they're often referred to as salts. The most common salt we know is sodium chloride, NaCl. In ionic compounds or in salts, there is a transfer of electrons, and you can see that here. Sodium transfers its one electron to chlorine. Ionic substances have very high melting points. They're soluble in water, which is why table salt will dissolve in water, hence salt water, like the ocean. And ionic substances will also conduct electricity in solution, or in aqueous solutions, making them electrolytes. They conduct electricity. Our next group is covalent substances. Covalent molecules are when two nonmetals share their electrons, like a tug of war. Covalent substances have low melting points and they're insoluble in water, meaning they don't mix, and they have no conductivity. There are two different types of covalent bonds. The first is polar covalent, which is when there are two different nonmetals sharing electrons unequally. You can figure out if it's a polar covalent bond by looking at the electronegativity difference. Electronegativity values can be found on table S in your reference tables. If you look up the two metals, for example, hydrogen and chlorine, and if you subtract their electronegativities and the difference between those electronegativity values are somewhere between greater than 0 and less than 1.7, then it's a polar covalent bond. However, if you then look to nonpolar covalent bonds, that's when there's equal sharing of electrons between two of the same nonmetal, and the electronegativity difference is 0. Lastly, we have metallic bonding. That's between metals. Electrons flow between metals, and we call this a sea of mobile electrons. These flowing electrons allow metals to be excellent conductors of electricity in the solid and liquid phase. They also have really high melting points. Next, in our naming and bonding, is molecular polarity. Molecular polarity can be determined by the shape and distribution of charge. We use SNAP, for example. SNAP stands for symmetrical charge distribution, nonpolar molecule, and asymmetrical charge distribution is a polar molecule. Let's talk about nonpolar molecules first. Nonpolar molecules have a symmetrical charge distribution, and they're symmetrical in shape. If you remember in class, I gave you that good trick that if the chemical formula ends in an even number, like 2 or 4, then it's going to be a nonpolar symmetrical molecule. Think about CH4, methane. Methane looks like a plus sign. That's symmetrical. All diatomic molecules are going to be nonpolar molecules as well. Polar molecules, on the other hand, have an asymmetrical charge distribution, meaning their charge is unevenly distributed, and their shape is also uneven. In a polar molecule, the last number is an odd number, so like 1 or 3 or 1 again. They can have dipole attractions or hydrogen bonding. Remember, hydrogen bonding is a very strong intermolecular force, and it only occurs between hydrogen and fluorine, oxygen, or nitrogen, because remember, fondue and the others don't. Lastly is BARF. BARF stands for break bonds, absorb energy, release energy, form bonds. When you break bonds, energy is absorbed, like an endothermic reaction. Remember, in endothermic reactions, the energy is written on the left-hand side of the reaction to represent that the energy is being absorbed. Making bonds releases energy, exothermic. In this case, the energy is written on the product side, on the right-hand side of the reaction. Atoms form bonds to be like noble gases. They either lose or gain electrons or share electrons to obtain the stable electron configuration with 8 valence electrons, or 2 if you're hydrogen. Also, something very important to consider is something like NaNO3. NO3 is a polyatomic ion, which you can find on table E in your reference tables. Nitrogen and oxygen are two nonmetals, so they exhibit covalent bonding. However, when they bond with sodium, that's going to be an ionic bond. Polyatomic ions, when combined with an element, exhibit both ionic and covalent bonding. That's really important to remember. And finally, molecule ion attractions. It's the process of dissolving. Opposite charges attract. If you look at my picture here, you'll see that the positive sodium is attracted to the negative oxygens. Opposites attract. That's all for now, folks. Have a good one.